quadratic number patterns, we need to figure out what the second differences are. So we're going to write out the pattern like we did with linear ones. We're going to find the first differences, and they will not be the same, and that's how you know it's not linear. And then when you find the second difference, you'll find that that's constant, and then we're going to work with each of those numbers with special formulas that you've got to learn off by heart in order to find the formula for the quadratic number pattern. We work backwards, starting with the bottom, the second differences. And in our pattern, which has A, B, and C that we need to find, we know that 2A equals the second difference. We solve that one and we get out a value for A. And then we say 3A plus B, and these are the bits you have to learn off by heart. 3A plus B equals the first difference, not the others, just the first one. But we already have worked out A, so then we sub in that number that we worked out and we get a value for B. So we sub in what we have for A and we work out a value for B. For C, we have A plus B plus C equals your first term, which is up there. And then you already have A, you already have B, and so you plug it into that formula and you come out with C. You put them all together, reminding yourself that A is the coefficient of the n squared, B is the coefficient of the n, and C is the constant term. Once you've found the formula for a quadratic number pattern, there are chiefly two kinds of questions. The first where they ask you for the value, and the second where they ask you for the position. The value will be when they ask for the third term, or in this case T100, and they give you the fact that it is the third term, or they tell you find T100. So when you're given the position, the 100, or the 5, or another number, you plug it into the formula in place of n, and you find out the actual value of the term that is in that position. However, when they ask you which term equals a number, they're asking for the position, and you need to plug in the number that they give you into the Tn. You're then finding the n. This becomes a quadratic equation, which you're quite familiar with, and you may have to use the formula in order to solve it. This one does factorize, but for most people this is quite difficult to factorize, and I'm recommending using the quadratic formula. Just bearing in mind you are going to get out answers that don't work. This one does work, but you cannot have a negative or a fraction or anything other than a natural number as your answer for n. It's very important that you strike through that to show that it is not an answer. A different type of question might be finding one of the actual terms in the sequence when they give you other terms in the sequence and you don't have the formula yet. If you're told it's quadratic, and in this kind of question you have to be, what you do know is that the first differences won't be the same, but the second ones will. So you work out your first differences and you have to use an x or an unknown in it, and it looks very messy. But when you get your second differences in terms of x, what you can do from there onwards is that you know that they're equal to each other. So you can simply take the second difference as it is and the other second difference, and you can make them equal to each other and solve for your unknown. Here is an example where two of the terms in the sequence are not given, and so we called them x and y. We were not told to do that, but it really did help. And we had to find out what T1 was, and they wanted the second difference. So we again found the first differences, which were all in terms of x and y, and then we knew that the second differences were equal. So same story as the previous example. These both had y's in them, this had an x in them, so we equated these and solved for y. So when we got the value for y, we got out that y was negative 11, which made the second difference 2. Knowing that, we could then solve for x, and x was actually the first term anyway. So then we had the answer to all the questions.